Alright everyone, today we are looking at the integral from 0 to 1 of the square root of x over the third root of x over the fourth root of x on and on to infinity. So firstly, whenever you see some sort of nested radical like this, you must always find some sort of way to simplify it. So we can isolate this nested radical and convert the root notation into exponential notation, and we are left with x over x over x with the first part over here to the 1/2, the second part to the 1/3, and the third part to the 1/4 right here. And then it goes on and on to infinity. From this we can then multiply the exponents and we get x to the 1/2 over x to the 1/2 times 1/3, which is 1/6, over x to the 1/2 times 1/3 times 1/4, which is x to the 1 over 24. And then this goes on and on to infinity. Using properties of exponents, we can then subtract all of the exponents from each other, and we are left with x to the 1/2 minus 1/6 minus 1 over 24. And then since we can find some sort of pattern from these exponents, they seem to be 1 over n factorial, which is 1 over 2 times 1 over 2 times 1 over 3, and then becomes 1 over 6, and then it goes on to 1 over 24. Then the next term would be 1 over 120, and on and on. So we could do minus 1 over n factorial. This is in order to generalize the infinite radical and infinite exponents. From this, we can just take a look at this exponential part and simplify it, and we get 1 over 2 minus 1 over 6 minus 1 over 24 minus 1 over n factorial. We can then distribute the negative signs, and we get 1 over 2. This becomes minus minus, so plus, and then we get minus 1 over 6 plus 1 over 24 minus 1 over n factorial. From this, we can see that this is actually equal to the series from n equals 2 to infinity of -1 to the n over n factorial. This -1 to the n term right here is just some sort of alternating term, so it goes from -1 to 1, -1 to 1, which is what we see here, -1, 1, -1, and on and on. And then the n factorial is what we see here, 2, then 6, then 24, then it would be 120, and on and on and on. From this, we can also compare this to the e to the x Taylor series, which you should have memorized, and it would be e to the x equals the series starting from n equals 0 to infinity of x to the n over n factorial. So from this, we can see that this is actually equal to e to the -1, since we have the -1 in the x's place. But this series here starts at n equals 2, whereas this series starts at n equals 0. So we have to subtract the first and the 0th term from this series. So we get minus the first term, which should be -1 to the 1th power over 1 factorial, plus -1 to the 0th power over 0 factorial. We can simplify this to e to the -1 minus -1 to the 1 is just -1, and it's over 1, so we just have negative 1. And then here you have negative 1 to the 0, which is 1 over 0 factorial. 0 factorial is 1, so this is just 1. These terms cancel out and we get 0, so this whole thing is e to the negative 1 right here. So from this we can plug this back into the integral expression and we get the integral from 0 to 1 of x to the e to the negative 1 dx. This can be solved very simply using the power rule or reverse power rule, and we get x to the e to the negative 1 plus 1 times the reciprocal of this, so 1 over e to the negative 1 plus 1. And then this here would be evaluated from 0 to 1. Evaluating this at 1, we get 1 to the e to the negative 1 plus 1, which just cancels out to 1, times 1 over e to the negative 1 plus 1, which is just 1 over e to the negative 1 plus 1. And then subtracting this expression evaluated at 0 using the fundamental theorem of calculus, we get 0, because 0 to any power is 0, and then it cancels out with this. So we get 1 over e to the negative 1 plus 1. We can simplify this further by stating that it is equal to 1 over e, since it's e to the negative 1 is just the reciprocal of e, so 1 over e, plus 1. From this we can get 1 over e plus e over e, which is 1, so it matches. And then we can combine terms since we have the same denominator, and we get 1 over e plus 1 over e. We can then flip this and we get e over e plus 1 as our final answer. And as always, if you enjoyed this video and want to help spread this to others, make sure to like and subscribe.